Hello, welcome to my channel. In this video, we are going to be solving problem under wave function. So the problem we are solving is given in the form of a statement. So we have the linear mass density of a string is 1.6 times 10 raised to the power minus 4 kilogram per meter. A transverse wave is propagated on the string and is described by the following equation. And the question is, determine the wave amplitude, B, the wavelength, C, the wave frequency, D, the speed of propagation, E, the tension in the string. So to solve this problem, it's important for us to know that this equation can be rewritten in a more general form as this. So this expression is the wave function of the wave. Our Y here is the displacement as a function of this expression, right? Our A is the amplitude, W here is the omega, K here is the wave number, and our X is the position, T is the time. Our W here can be written as W equal to 2 pi F, which is equal to 2 pi all over T. Our F here is the frequency, capital letter T here is the period. Our K here, which is the wave number, can be written as K equal to 2 pi all over lambda, where our lambda here is the wavelength. So from the question we have to find the wavelength, so we'll come back to this. Now, if we substitute this and this into this expression, we get Y equal to A sine 2 pi T all over capital letter T. This is the time, this is the period. This one is 2 pi X all over lambda. Now what we'll notice is that 2 pi is common, so we can factorize it to get A sine 2 pi. We are left with T, small letter t all over capital letter T, X all over wavelength. So from the first question, if we compare this with this, we see resemblance. 2 pi, 2 pi. Our A here is 5. Our T here is T. Our period here is 0.03. Our wavelength is already determined, which is 50. So from the question, we asked to determine the wavelength, the wave amplitude. So the amplitude is A, which is 5. So we have A equal to 5 centimeter. Then the next thing is the wavelength, which is lambda. So if you compare this lambda, which is the wavelength, compared to this, you realize that our lambda is 50. So we have lambda equal to 50 cm because our amplitude here is in cm. So wavelength is cm, and if we convert to meters, it becomes 0.5 meters. Then the next question is the wave's frequency. From here, we notice our period T here, capital letter T, is equal to 0.03. And if we check out this formula, we notice that F is nothing but 1 over capital letter T. So we can get our F from this formula, which is F equal to 1 over capital letter T, 1 over 0.03, and that gives us the 3.3 hertz. So the next question we're asked to look for is the velocity of propagation of the wave. And we can use this formula, V equal to F lambda. Our F is already known. Our wavelength is 0.5 meters. So if we call up those parameters, we'll multiply, we'll get 16.65 meters per second. Then finally, we're asked to calculate the tension in the string. To calculate the tension in the string, we use this formula, V equal to the tension all over the mass per unit length of the string. We know this, which is this. We know this. We're asked to look for the tension. So we can make the tension subject formula. It becomes V squared times mu. If we plug in our parameters here, we have this expression. And finally, our tension becomes 4.44 times 10 raised to the power minus 2 Newton. And that's it. I hope this helps. Please like, share, and follow for more. Thank you.